For centuries, we believed volcanoes were uniquely earthly phenomena, molten rock erupting from within a living, geologically active planet. But space exploration has rewritten that idea entirely. Volcanoes are everywhere in the solar system. From the towering mountains of Mars to the lava fountains of Jupiter's moon Io and the smoldering plains of Venus, alien eruptions are not only real, they're redefining how we think about planetary evolution, geology, and even the potential for extraterrestrial life. In this segment of Infinity Beyond, we take you on an interplanetary journey through the most powerful volcanic worlds beyond Earth. Let's begin with the giant among giants, Olympus Mons on Mars, rising 22 kilometers high, nearly 3 times the height of Mount Everest. Olympus Mons is the largest volcano in the entire solar system. Its base spans 600 kilometers across, and its gentle slopes suggest it was built by slow, massive lava flows over millions of years. But here's what's truly fascinating. Olympus Mons is so huge because Mars lacks tectonic plates. On Earth, magma rises through shifting plates, spreading eruptions across different regions. But on Mars, the crust is fixed. This allowed magma to well up in the same location again and again, forming a superstructure of unimaginable scale. Is Olympus Mons still active? Possibly. Some researchers believe there may have been eruptions as recently as 2 million years ago, very recent on a geological timescale. Next, we head to one of the most violent volcanic bodies in the entire solar system, Io, a moon of Jupiter. Io is unlike anything in the solar system. Its surface is constantly erupting with lava fountains, plumes, and sulfur geysers that reach hundreds of kilometers into space. These eruptions are caused not by internal heat from radioactive decay, like on Earth, but by tidal heating. As Io orbits Jupiter, it's pulled and stretched by the planet's immense gravity and the gravitational forces of neighboring moons. This flexing creates friction and heat inside Io's core, fueling endless volcanic activity. Some eruptions on Io are so powerful that they've been captured from Earth-based telescopes. One eruption in 2007 sent material 330 kilometers above the surface, an eruption visible across millions of kilometers of space. Io is the most volcanically active world we know of, and it offers a glimpse into what extreme geological activity looks like in environments very different from Earth. Then there's Venus, Earth's twisted twin. Shrouded in dense clouds of sulfuric acid and with surface temperatures hot enough to melt lead, Venus once appeared geologically dead. But recent radar imaging has shown possible signs of active volcanism, including hotspots, dome formations, and surface changes captured between satellite flybys. Unlike Earth, Venus doesn't have plate tectonics. Instead, it may undergo catastrophic resurfacing events, where massive amounts of lava erupt across the entire planet every few hundred million years. But smaller, ongoing eruptions may also be happening beneath the clouds, possibly releasing volcanic gases into the atmosphere. One particular volcano, Mons, has been identified as a likely candidate for recent activity, and upcoming missions like Veritas and Envision will investigate further. Why does this matter? Because volcanoes play a critical role in shaping planetary environments and potentially supporting life. On icy moons like Europa, Jupiter, and Enceladus, Saturn, volcanic activity takes a very different form. Instead of molten rock, these worlds have cryovolcanoes, which erupt liquid water, ammonia, or methane. These icy eruptions may indicate subsurface oceans, heated by tidal forces and insulated by thick ice crusts. In these hidden oceans, powered by volcanic vents, scientists believe life could exist, not unlike the microbial life that thrives near hydrothermal vents at the bottom of Earth's oceans. Volcanoes, in this sense, aren't just destructive. They're potential life givers. They provide heat, nutrients, and energy in otherwise frozen, hostile environments. They may even create atmospheres by releasing gases over millions of years, a process thought to have helped shape Earth's early climate. As we explore the solar system, we're starting to see that volcanism is a universal process, one that transcends Earth and connects us to distant worlds. Each eruption, whether it happens in Wyoming or on Jupiter's moons, tells a story about a planet's interior, its evolution, and its potential to host life. So what's next? NASA and ESA missions are set to explore these alien volcanoes up close. Europa Clipper will fly by Jupiter's moon to study its icy plumes. Mars sample return may help determine the age of Olympus Mons' last eruption. And Veritas will peer beneath the toxic veil of Venus to find out just how active our sister planet really is. At Infinity Beyond, we believe that understanding alien volcanoes may unlock the biggest question of all. Are we alone in the universe? Because where there is volcanic heat, there might be life. In Segment 10, we'll look toward the distant future. Could humanity one day live on or near alien volcanoes? Could we harness their energy, or will we always have to fear their power? The science fiction is becoming science fact. Stay tuned, stay curious, stay with Infinity Beyond.